Have you ever wondered what goes behind making that delicious latte that you can get every morning? Well, in this video, I'm going to break it down into 5 steps that goes on behind that espresso machine, and the result is going to be a delicious cup of latte. Hey guys, I just want to take a few seconds to thank every single person who has supported me so far. The announcement of my new YouTube channel last week was so amazing, and I just got so much positive feedback from everyone, and I'm so thankful, and I'm really excited to start this with you guys. The first step in the system is the water. Our water source is either going to come from a water reservoir in smaller espresso machines, or it's going to be connected directly to your pipes. Usually in coffee shops, they have it directly connected to the pipes for low maintenance and large scale use. Okay, so the second part of our system is a pump. The pump's purpose is basically just to pressurize all of the pipes within the espresso machine. So there are 2 types of pumps that you often see in espresso machines. The first one we're going to talk about is a vibratory pump. So a vibratory pump gets its name because of the piston that is vibrating back and forth. So why is this thing vibrating in the first place? Well, what's going on is you have electrical energy that comes from your power source, and it is being translated into magnetic energy. And this is going on because of an inductor. It's a fancy word for a bunch of coils that have current running through them. So we know that current running through a coil produces a magnetic field. So this is an AC current, alternating current. It's the kind that you see whenever you plug into the wall, but basically what it's doing is it's going back and forth, it's alternating. So what does that mean for our inductor? It means that the magnetic field is produced during the positive half of the current cycle. But what happens during the negative? Well, there's this weird little thing in there called a diode, which makes the current stop whenever it's going in the negative portion of the cycle. So what's going on in that piston? Why is it vibrating? Well, the magnetic field during the positive half is making that piston, which is connected to a big spring, push against the spring and compress it. And that creates a lot of potential energy because that's not supposed to happen. It takes energy to do that. And then allowing water to flow into the chamber, the little pressure chamber during that time. So what happens whenever it's in the negative cycle? The spring is going to push the piston back into its normal position and pushing all of that water that came into the chamber out, hence pressurizing all of the pipes. One thing to note about a vibratory pump is that it has a lot of pressure oscillations, which basically means that they're going like this, up and down, up and down. And that is not good whenever you have high volumes of espresso needing to be made. So that's why that these are usually for home use or smaller scale espresso machines. And also, this pump has a lot of little pieces to it, a lot of little O-rings and rubber, and those wear out easier than the rotary vane pump, which we're going to discuss next. So the next kind of pump we're going to look at is often used in large scale coffee shops. So it has a shaft that's in the middle of 2 cylinders that are concentric. They're just different sizes, and so they don't align up properly. So you have this shaft rotating in the middle, and there are 4 vanes on each side. They're being pushed as far out as they can go as this thing is spinning. So because the 2 cylinders are concentric, little water is seeping into them during that small little piece that you can see right there. As this thing is rotating, the vanes are collecting water in between while the shaft is rotating and then pushing it out the other side. So I mentioned the pressure oscillations with the vibratory pump, and the rotary vane pump doesn't have this because by the time the last vane is pushing water through the outlet, the next one is ready to push water through. And so it's never really oscillating. It's very constant, which is good when you have a lot of espresso to make. Something else to note with the rotary vane pump, it is bulkier, more expensive, but also quieter and has, like I said, no pressure oscillations. So that's why it's ideal for coffee shops. Okay, so enough about pumps. We're moving on to the next step. Step 3, it's our boiler. So the boiler is this big tank. It's enclosed, but it has these coils at the bottom that heat up and basically transfer energy from the heated coils into the water. This water that's contained is heated to about 255 degrees Fahrenheit. which we know is above the boiling temperature of water. So it's basically going to make a bunch of steam within this boiler. Now, the steam is going to be taken out of the boiler on top and go to the steam wand, which we know makes the delicious frothed milk to add to our latte. But the boiler isn't just used for making the steam and that goes to the steam wand. It also has the use of transferring heat. Now, that's going to be the next step in our process. We're basically going to have a heat exchanger. So you have this pipe that is running through the boiler and water is running through that pipe. So you have water running through a pipe which is colder than the steam which is around it. So we know that heat goes from hot to cold. That's the way that energy flows. So when you have this pipe running through the boiler, all of the steam, the energy that's in the steam is going to want to go into the cold pipe water and heat it up. But it's not going to be as hot, obviously, and you're just going to get a really nice hot liquid around like 200 degrees Fahrenheit that is going to be used to go to our group heads, and we'll get to those in a little bit. Okay, so during all of my research, every time this espresso guru would get on there, they would talk about the group heads. They'd be like, it's where all the magic happens. I don't know, these things, I just learned about them recently. But basically the group head, it has a couple of different parts. The first part we're going to talk about is the chamber. So imagine you're a barista and there's a little part next to the group head, and whenever it's not being used, it's like pushed all the way up. So you see that chamber right there? Well, water from our heat exchanger, the pipe that we just talked about coming from the boiler. So water that's heated goes into the chamber, and basically it's just going to be swirling around and then exiting, but it's going to be keeping the top of the group head really warm, and it's going to be nice and hot. It's going to be like stabilizing the temperature that comes out of the heat exchanger. Just in case there's any temperature variations, it's just going to stabilize it. So your barista walks up and they're trying to make espresso. And whenever the barista pushes the lever down, it allows water to flow out of the chamber through a series of pipes that end up going through all of our espresso grounds, making the delicious espresso that we can mix with the steamed milk that is frothed from our boiler, like we mentioned earlier. And so the result is a delicious cup of latte from espresso and the steamed milk that you get to enjoy, and we all get to enjoy, and it's very happy. Okay, so I hope we learned a little bit today about how to make a delicious latte, things that go behind it. Heat exchangers and boilers and pumps are things that we see all the time in mechanical engineering, but they don't sound as interesting unless you put them, in an espresso machine. Okay, so that's the end of our video. I hope you guys learned something today, but also I really would love to know what you guys want to hear and learn about. So please put it in the comments so I can know and see what you guys are interested in. Don't forget to press my subscribe button, like the video, the shindig, but see you next week.